Hello, I am Susobhan Ray. Currently, I am working as an assistant professor in ECE department of SDIST. Last lecture, I have discussed the timing diagram of Intel 8085 microprocessor. Now, today I am going to discuss the several interrupts of Intel 8085 microprocessor. So, what is interrupts? An interrupt is a signal to the microprocessor that an event has occurred, okay, requiring some immediate action after getting such kind of signal. So, there are two kind of interrupts exist in processor. One is software interrupt, another one is the hardware interrupt. So software interrupts means the instruction set of a processor includes with different kind of restart instructions. So here in Intel 8085 processor, there are 8 number of restart instructions. There are RST0, RST1 up to RST7. So these are going under the software interrupts, and each and every interrupt has some vector address. For example, for RST0, the available vector address is 00H, and for RST7, the vector address is 38H. Okay. Now, next, the hardware interrupts. In Intel 8085 processor, there are 5 hardware interrupts, such of them the trap, then the RST 7.5, RST 6.5, RST 5.5, and INTR. Each and every interrupt has some vector locations. Exclude the INTR, which is the lowest priority interrupt, and which is sometimes is called a non-vectored interrupt. In this slide, I have discussed the interrupt structure of Intel 8085 microprocessor. Okay. So, apart from that, the microprocessor basically provided with CPU and various bus control signal, and one important CPU control signal is the interrupt. Okay. So you have already seen that in Intel 8085 microprocessor provided with a number of interrupts, and in this above diagram, the hardware interrupt which is provided by 8085 is nicely depicted over there. You have seen there are 5 number of interrupts are available in Intel 8085, out of which the trap is the highest priority interrupt, and this is obviously the non-maskable interrupt. That means if it comes from any external source or any external device to the CPU, will be interrupted. Whenever the CPU gets interrupted, the control flow of execution of an instructions will change. So the CPU will complete the executions. After that, it will branch to a particular memory locations. That particular memory locations has been specified for trap is 24 hex. This is the vector address locations which is already given there. So why it is called vector address? Because it is a fixed locations. In this particular case, the PC or the program counter value always initialized from this particular locations, which is 0024x. So that is why this is called the vector address. So that means the interrupt service subroutine corresponding to trap will start from 0024x locations, and after that the subroutine executions is over, and then it will returns from that subroutine, and the program counter value which will be stored into stack and will be recovered, and the program counter will be initialized by this particular value. So as you can see the sensitivity level, the trap is sensitive in both levels. Okay, if there is a low to high transition, the trap will be activated. The trap instructions is sensitive in both levels, that means high level and low to high transitions. And so trap is a non-maskable and got the highest priority always. And the other interrupt features also depicted over here. They are RST 7.5, RST 6.5, RST 5.5 and INTR. Okay. So what do you mean by this priorities? Yeah. So after trap, the second highest priority interrupt is RST 7.5, then RST 6.5, then RST 5.5, and finally the lowest priority interrupt among all of these is INTR. So what do you mean by the priority? Priority means suppose RST 7.5, 6.5 are activated simultaneously. So which one will be selected by the CPU? Okay, it will depends upon which one have the higher priority. Oh, okay, so that will be activated. Now, what is mask bit or maskable interrupt? That means a programmer can disable all of these kind of interrupts by setting a several flag bits. Okay, and this is basically done by using some EI, that means enable interrupt, and DI or the disable interrupt pins. With the help of this, you can easily disable the entire interrupt systems. So that means, according to this diagram, when EI is low, none of them, the interrupt will be activated. If EI is set to 1, that means high, then all of this will be activated. On the other hand, if you executed the disable interrupt, or there any interrupt is recognized, then there is automatically the interrupt system will be disabled. Okay, so EI is 0 and none of them will be activated, and when all the interrupts will be disabled by executing an instructions, then it will be called a disable interrupt, and all of these interrupts will be enabled by executing an instructions, which will be called the enable interrupt or EI. So moreover, these interrupts have some several mask bits and they will selectively mask. Okay, so using EI and DI instructions, you can enable or disable all of these interrupts, which I have already told. But if you can do enable the interrupt system but want to disable some of the interrupt among all of these, then it will be done by some programming, and this is nothing but is called mask values, which are some mask bits, and these mask bits are provided generally inside the CPU, which can be programmed by using an instruction called SIM or the SIM instructions, set interrupt mask. With the help of SIM instruction, the flag bits M will be set or reset. So that means it is notable that using mask bits M, we can selectively enable or disable all interrupts according to our basic needs. Okay. So now if we observe this particular diagram, you can see the sensitivity is also different for different interrupts. For RST 7.5, it is age sensitive. For RST 6.5, this one is and RST 6.5, RST 5.5, and INTR, all of these are level sensitive. So that means RST 7.5 is age sensitive, and for RST 6.5, RST 5.5, INTR, all are level sensitive. So when mask bit is set to 1, then all interrupts will be deactivated according to this particular diagram. Whenever interrupts occur, whether it will be activated not depends upon two things. When EI lines and mask bits 0, then RST 7.5 will be 1 or RST 7.5 will be activated. Since it is age sensitive, okay, we require a flip-flop to store the particular informations. Here it is visible. If it is level sensitive, don't require any flip-flop for storing informations, and in case of RST 6.5, 5.5 and INTR, they don't require any flip-flop because they are level sensitive. Okay, so for level sensitive, we have not needed any flip-flop. So in this slide, I have discussed the triggering of different interrupts. So if we carefully observe this particular diagram, you can see that INTR is level triggered, RST 5.5, RST 6.5. These are also level triggered, but RST 7.5 is age triggered. Okay, and trap, which is called the highest priority interrupt, this one is also level triggered and as well as age triggered. Okay, so in case of trap, RST 7.5, RST 6.5 and RST 5.5 all have fixed address locations or vector locations, which is already shown over there. So all of these called a vector address. Okay, so that means when interrupt occurs, these lines, the processors will basically jump to any fixed locations. But in case of INTR, you can see there is no fixed address locations. So that address is supplied by some external device, which is known as the interrupt controller. So what is interrupt controller? It is a device used for interrupt driven data transfer. This is provide where the CPU will jump when the interrupt has been occurred. Okay, so that's all. Thank you.